Yes, sir. I included you. Kindly share your PPT.
Yes, sir. I can now. I can. Yes, sir. Now is it visible, sir?
Visible, sir. One minute, sir. 1 minute, sir. Dear participants, sorry for delay in the starting of this meeting. Today's lecture. Welcome to 5-day online faculty development program sponsored by AICT Atal Academy on challenges and opportunities on collection, storage, and utilization of solar thermal energy. It is my pleasure to introduce Dr. R. Velraju, Professor, Institute of Energy Studies and specialized in heat transfer, computational fluid dynamics, and energy storage. He was the administrative position as Deputy Director, Center for Affiliation of Institutions for 6 years from 2004 to 2010, Director AU FRG Institute for CAD-CAM for 3 years from 2010 to 2013, and Director Institute of Energy Studies for 5 years from 2013 to 2018. He received several awards. Few are DAD Award for his doctoral research in Germany during 1995 to 1997. Tamil Nadu Scientist Award 2014 by Government of Tamil Nadu. Achiever Award by Appadurai Chai TNEV in the year 2017 for his technology contribution to TANGEDCO. Active Consultant Award in 2011 by AU. Best Innovation Award in 2013 by AU, Research Excellence Award in 2019 by CTTD Anna University, Distinguished Research Award in 2019 by Anna University. His research credential 15 sponsored research projects as Principal Investigator PI, 203 research articles in journals of high repute H index 47, 35 PhDs completed, 11 ongoing. Executed 37 consultancy projects as principal consultant. He is an expert member in various international and national forums in the field of research, reviewer for several international journals, affiliate and member of governing council, board of studies for various universities, autonomous institutes, serving as expert member, governing council member for various international research forums, government bodies like Raj Bhavan, TEDA, IEI, Science City, TIDCO, TIPEL, PARC, IRL, NRC, NIOT, Samir, AICTE, US, consulate reviewed universities and institutions, and also for government funding bodies like MNRE, DSP, NIVI, and TNSCST. Thank you, sir, for your gracious presence, and now I invite you to give a talk on the solar thermal energy storage systems.
Thank you, sir. Thank you very much for the opportunity given, sir, to present a lecture on your faculty development program on challenges and opportunities in collection, storage, and utilization of solar thermal energy. I am very glad to share my experience and thoughts on this topic on thermal storage, on which I have done some research for some few years. So, very good morning to one and all. So, this topic, I think the last 4 days you have been listening various topics on solar energy collection, storage, utilization. It's maybe more focus on solar. So, I would like to start with a brief introduction. Maybe it may be I do not know what kind of introduction you have received in the earlier presentation, but still I would like to give some 5 to 10 minutes introduction about the energy challenges in this country, because some of you would have already listened my lectures. Maybe it's the same thing, but some of you are new to this workshop. So I would like to give a small introduction, the challenges presently facing by our country, and how this solar energy, why this solar energy, why we should move to solar energy, what way you can enter in solar energy, all these aspects. Now, though my focus is only on energy storage, I would like a brief introduction about that. So, energy challenges. So, in the last 2 decades only, our power generation capacity has increased appreciably. When we got independence in the year 1947, our total power generation capacity in the entire country was only 1,500 megawatt. You just imagine, 1947, it was 75 years ago, it was only how much? 1,500 megawatt. Even 2000, around 2000, it was less than 1 lakh megawatt. Now in the last 20 years only, the power generation capacity has been increased appreciably, and it is now nearing 4 lakh megawatt. But still, our requirement is increasing appreciably, because the fast development in our country took place in the last 2 decades only. We can tell the high-rise buildings. When 200 years, some 20 years ago, there was no high-rise building in our city. Chennai is a big city only. There were only 2 high-rise buildings, that LIC building and one more building was there. But now there are some, in the last 20 years, there were more than some 300 buildings, high-rise buildings have come in the city. Like the same scenario in most of the major cities in India. So the power requirement has been increased appreciably in the last 2 years. But still, we are short of some 25 to 35 gigawatt in the peak demand. We are not able to meet the peak demand all the time. To meet the peak demand, what we do, we shut down power in some places and meet the emergency requirement or the essential requirement we are meeting by adjusting, making some shutdown in some places. That is how it is being done even now. We are short of 25 to 35,000 megawatt shortage as of now. And another piteous thing is 160 million, 16 crore people are still having no access to electricity in the country. This scenario was 30 crores some 10 years ago, but the present government has given lot of avenues, that is using photovoltaic systems were made in some remote areas. That is how this scenario that is has decreased appreciably. Some 10 years ago, it was 30 crore people have had no access to electricity. Now it is 160 million. That means 16 crores. Even now, there is people are living without power connection. They manage with the local arrangement. And 23% of the generated electricity is lost in transmission and distribution in India. All these years, the major power generation is through what? The coal-based and large capacity power generation. When this generated power is transmitted through remote areas, India is such a large country, to all places, the transmission and distribution become very expensive. Also, during this transmission, there is a heavy loss. So that means with the power generation through large capacity power generation results 23% loss in the transmission and distribution, and 40% of the carbon dioxide emission, because when you burn these coal fossil fuels, there will be a lot of carbon dioxide emission. So 40% of the carbon dioxide emission is due to converting power from fossil fuel. Now there is a electric vehicle is coming. When the electric vehicle comes, there is a lot of opportunity for solar utilization to play a major role in vehicles also. And this transmission also incur lot of investment cost. 25 to 40% of the total electricity supply cost is also from network services. So now, having understood this, you could understand the need for local power generation like the solar, wind. Among these, some 1980s to 2000, these 2 decades, the power generation capacity increased appreciably in the wind sector. But after 2000, that too after 2010, after the introduction of Jawaharlal Nehru solar mission, the solar power increase is very high. after the introduction of Jawaharlal Nehru Solar Mission in 2010, the increase in solar energy capacity has increased appreciably. It's not only power, everywhere. It's a solar, thermal, solar, all applications. This is increasing appreciably. Okay, so this is the energy scenario. So emerging needs for renewable power and energy storage. Now I am coming to energy storage. So this is the scenario which shows, this red line shows what? Fossil fuel power consumption. As of now, 1000 terawatt hour is being used, generated in this country per year. It's hereafter, mostly all these years, we have been telling the power generation with some megawatt, gigawatt, terawatt. But when the renewable energy is going to play a major role, because this renewable energy will not deliver power all the time. So capacity, telling the power generation in capacity will not give the full meaning, because throughout the 24 hours or all the 365 days, that will not deliver power. So per year, how much it is generating, because windmill in some location will deliver power some 6 months. Some areas it is 4 months. Wind, the solar energy also, it is varying. Diurnal variation will be there. Every day, some 8 hours or 6 hours only it will deliver power. So the capacity you cannot just multiply with some 24 hours and 365 days. You cannot do that. Like coal-based power generation, how much energy you can generate. So it is telling in terms of energy generation per year is the best option hereafter. When the renewable energy generation is increasing in the total power generation mix, we can tell what is the power generation means. Its energy generation is best. That is in terawatt hour, kilowatt hour. So as of now, it is 1000 terawatt hour is the energy generated in this country. It is going to increase 7,000, seven-fold increase is going to happen in another 3 to 4 years. Another 3 to 4 years, seven-fold increase is going to happen. That is 30 in another 30 years, not 30 years. So 20 years you can say. So, but you can see the gap between this green line and the red line. That is the renewable energy contribution. That renewable energy contribution is going to increase appreciably in the coming years. So again, the right hand side graph shows the global atmospheric, why the solar energy is popularized in a large scale, because of the atmospheric pollution, global warming, all these environmental problem only leads the directed the global, all the countries to march towards, that is the action towards renewable energy utilization. Okay, so this right side graph shows the carbon dioxide percentage in the atmosphere. So if we use fossil fuel for all our energy requirement, even for industrial, thermal requirement, everything, if we use fossil fuels, the carbon dioxide percentage increase in the atmosphere will increase appreciably. Okay, this carbon dioxide at the time of evolution of the earth, it was only 65 ppm, parts per million. There are various gases, poisonous gases or polluting gases coming through industrial activities and various other activities. But everything you can convert in term equivalent to carbon dioxide. For example, methane is coming from some waste accumulated in some place. That methane gas is 21 times vulnerable than carbon dioxide. So you can account everything in terms of carbon dioxide. But the carbon dioxide percentage itself is only 65 ppm at the time of evolution of the earth. Before the industrialization started some 200 years ago, it was only 265 ppm. 265 ppm. Only in this last 2 centuries, you can see there is a flat curve from, it is shown from 1000 years to 700 or 800 years. Till that there is no increase in carbon dioxide. 1000 years is very small. There is no, when there was no industrial activities, no carbon dioxide increase. The same trend was there for several millions of years. Slowly there was a small addition. But when the industrial activity started some 200 years ago, when we invented electricity, automobiles, the carbon dioxide emission increased appreciably. So after 1800 only this increase started, and within 200 years, in the year 2000, it was 365 ppm. Then in the last 20 years, the increase has been a very appreciable variation is there. Appreciable increase is there. So 365 became, now it is 4, this is 2000, in the year 2000. Okay, in the year 2020, now it is 415 ppm. 415, within 20 years, the ppm level increase is 35 ppm. That means it is average, it is more than 1.5 ppm. But presently, in the last 2 to 3 years, it is more than 2 ppm. More than 2 ppm, 2 to 2.5 ppm per year, it is increasing. And continues, the days are not too far to achieve, to come to a level of 600 ppm. Why I am telling 600 ppm? When this carbon dioxide level in the atmosphere reaches 600 ppm, no human being can exist in this planet. We cannot live in this planet. Before that, all other animals, birds, and everything will get extinguished. So, for 600 is human being, knowledgeable person also cannot live beyond that. Okay. So, otherwise we should live always with the oxygen, an oxygen container, and in that atmosphere only human being can live. Normal atmosphere we cannot live. Even this pandemic is also maybe due to this increase in carbon dioxide leads to various kinds of diseases, that viral and other things, that now we are able to live only with the mask. But this scenario will change even after some 10 years. It may change into that we can live only with the oxygen containers. So that scenario also may come. So now, having understood this scenario, the global organizations have trusted all the countries, environmental scientists have trusted their countries' administrators to change their scenario from fossil fuel utilization to renewable energy utilization for all our requirement. That is how this wind energy came. Then the solar energy is now the talk of the day. Okay, now this is the major pathway towards the solar energy. In the year 2008, based on the thrust from various environmental organization and world organization, our government was forced to make National Action Plan on Climate Change. National Action Plan on Climate Change. This was formulated in the year 2008. So after that, based on that, 8 missions were initially envisaged. 8 missions. These are all not that 8 missions. That is, energy storage mission came very recently. Initially, based on that, this wind energy mission and Jawaharlal Nehru solar missions are that 8 missions. After that, from that, several other missions also envisaged. Okay. So out of that, the smart grid mission is one of the mission to transfer this power generated in an efficient way. That is also when the renewable energy mix in the total power generation increased, the grid became unstable. Then that is how this smart grid mission came. But in the year 2010, based on the National Action Plan on Climate Change, one of the important mission was this Jawaharlal Nehru solar mission. So I have shown here all the missions that are connected to energy, And the Jawaharlal Nehru solar mission was that was envisaged in the year 2010. So that time the objective was to achieve 20,000 megawatt through solar energy before 2022. 2022, we want to achieve how much? To 20,000 megawatt. That was in the year 2010 we have planned, because our target, our vision itself was too less that year. Okay, because we couldn't imagine, because that time there was not even 1 megawatt. Okay, so we within 12 years we wanted to achieve 20,000 megawatt. But now after few years, then this government has changed our vision to 1 lakh megawatt through solar and other renewable energy. Then now it is changed to 223 megawatt before 2022. 2022, why 2022? Because our 75th year of independence, right? 45. So 47 plus 75, 2022, we want to project some achievements. So everything is targeted towards 2022. So our target is now to more than 200 megawatt through solar and other renewable energy. It is in this more than 1 lakh megawatt is through solar. Okay, that total data, what is our target? So this is our present energy generation capacity through various mode. So this is our revised target in the goal for 2022. In that, through solar is 113.49 gigawatt. That means 1,13,490 megawatt. So totally 227 gigawatt we are hoping to get from these renewables. Maybe this last 6 months or 7 months corona pandemic also may shift this to another 1 year, but our target is to achieve before 2022. Okay, this is about the smart grid. Now I will come to energy storage, but that too particularly about thermal storage, because our target is, it's mostly towards the mechanical engineering researchers and students. So it is solar thermal energy. Solar energy is a thermal energy. Am I right? Now I come to thermal part. Solar energy. So most of the electrical energy generation is from thermal energy. Am I right? From fossil fuels only energy is generated. Most of the energy is generated. Our primary source of energy is solar, which is thermal form. Thermal energy is only converted into different form. So different type of heating in the different parts of the world creates wind. So through wind also we generate power, which is because of differential heating in different parts of the world. Okay, so ocean thermal, it's also differential part of heating. So all biomass is also because of solar thermal energy. So everything fundamentally it is from solar thermal. So that energy now directly we are able to convert into photovoltaic cells and into electricity. So that light energy is converted into electrical energy. That is one mode of generating energy. Okay, now for all our lifestyle, we need electrical energy. Whether it is coming from what mode it is, doesn't matter. Mostly it is electrical energy, and thermal requirement is also very high. Now my focus on this energy storage will be on thermal part. Even electricity we are using for thermal requirement in many applications. One of the major application is what? Space heating and cooling. Am I right? In any of the country, in most of the countries, nearly 40% of the electrical energy generated is used in building sector. Out of that 40%, 60% is used for space cooling or heating. Right? In building, out of the total energy utilized, more than 55 to 60% of the energy is used for space heating or cooling, depending on whether it's a cold country or hot country. Okay, so totally 60% of the 40, that means 24% of the energy, whether it is electrical energy generated, is used for thermal application. There only our mechanical engineer's role is there. You should understand 24% of the electrical energy utilized, generated is also again utilized for thermal requirement. Thermal requirement means space cooling. We use high capacity vapor compression system. That means energy intensive compressor we use in the vapor compression refrigeration system to produce cool energy, to transfer the heat energy from one end to the other end. That means to produce cool energy. Cool energy is a thermal energy. Am I right? The energy is a thermal energy. So that directly you can also generate from vapor absorption system from solar vapor absorption system. Okay, now you understood. There are lots of, not only this space cooling and heating, food preservation is one area. Food preservation is one area. There are lot of process industrial application where you need heating. There are some furnaces being used electrical energy, but thermal energy also can be used. Okay, so there are so many applications where electrical energy generated is being used for thermal application. Now the problem comes. So need for energy storage is this slide is telling about need for energy storage. Need for energy storage. Why you need energy storage? Because now the whole world is shifting towards renewable energy. That why I have told about the reason I have told. Because of the large emission of carbon dioxide, we cannot use the fossil fuels. So obviously for all our energy requirement, we need to go for renewable energy. But this renewable energy is highly intermittent in nature. So since it is intermittent in nature, we cannot use whenever we want. The supply demand mismatch will be there. So there are so many ways to bridge the gap between the supply and demand. The gap between the supply and demand. Solar energy, okay, you can accumulate some heat energy in a tank, and then whenever you want, you can use it. Right? So you need to know, that means some storage system is required. So storage become essential when renewable energy percentage keep on increasing. So small percentage means we can manage, because this electricity transmission grid is also like a bank. Okay, in the bank, okay, somebody will put energy, wind energy, somebody will put, and somebody will add energy generated from solar photovoltaic, somebody will put energy generated from solar thermal power plant. So various, but when this percentage of renewable energy is less, this bank can manage. The bank is the transmission grid, the grid. So there is a banking and wheeling concept is there. So you can bank your energy in the transmission grid to some extent when the percentage of renewable energy generation is within some 15%. Okay. Now in the now the whole country, if you see the percentage of renewable energy is more than 17%. Now it may be 18%. Okay. The renewable energy contribution in the total power generation is 18%. When it goes beyond 25%, there will be a total chaos. That grid will become unstable. Then without storage, you cannot manage. Now the most of the developed nations where the percentage share has already been increased, they are trying to manage with the various means. Various means. One of the first easiest method is that is changing the pricing policy, dynamic pricing for the energy utilization. So whenever power is available plenty, that time if you allow the price at a lower price, means what people will, the customer who is using energy, what they will do, they will try to utilize the energy. Their office hours also they will change. Right? Suppose if you use the price is less, whenever the power change, all the household people will operate their washing machine and pumping, water pumping, everything during that hour. And industry also may shift their operating time based on the energy availability if the particular industry is energy intensive industry. So like that, lot of scenario change may occur if you make dynamic pricing in the electricity tariff policy if you make. Okay. So these kind of things are happening in most of the countries where when the renewable energy share is increasing. And the other thing is, so through controls. So controls means we can we can instruct the coal-based power plant to shut down this power plant or to operate the power plant at part load when the free electricity is available through solar or wind. Because there we are not using any raw material. Investment already we have made. So this all these renewable sources must be in must-run condition. That means Whenever source is there, we should allow them to operate, and that energy we should utilize somehow. That is called must-run concept. So when must-run concept is there, we should instruct the fossil fuel-based generators to shut down their operation. Am I right? Or to operate their mills, plants with the part load. Then only we can use this, because we cannot use all the power generated when it is more than the requirement. More than the requirement. There is though we are short of 25,000 megawatt, there are times in a day when the power is excess. When the power is excess, because 25,000 megawatt is a small quantity out of 4 lakh megawatt. 4 lakh megawatt is not required all the time. Am I right? Sometimes we may.
Hello, sir. Your voice is not coming.
Maybe some network issue.
Yes, yes. It will come. Just please wait for 1 minute. I'll call. I think it is network problem. I think it's reconnecting.
Don't worry, sir. We will wait.
Professor is reconnecting, I think. So. Dear participants, I mailed the invitation to valedictory and also the particulars about the examination. Are you received the invitation as well as the particulars?
Yes, sir.
Okay,
Yes,
okay.
sir.
Thank you, and I'm going to send the link.
Sir,
Your exam is 2:30. 5 to 10 minutes before I will communicate the link. Google Form.
Sir,
Yes, tell me.
sir, our college network suddenly has gone, I think. So now it has come.
Okay, sir. Thank you, then. Yes, yes.
Okay, so I will share. I can share now, no, sir? Yes.
Yeah, now we can share, sir. You are in presenter now. We can share.
Yeah, yeah.
Yes, yes.
Can I proceed for another 15 minutes or?
Yes. Okay, sir. No problem. No problem. You can proceed,
No,
sir.
actually,
As
what
per
is the
your,
time, sir? 9:32?
No, sir. You can proceed. No.
Yes.
Content.
Then,
No, you have freedom to proceed. No.
Okay.
Today only yours lecture, sir. All
Yes,
lectures
sir.
are completed.
So in the middle, I can break for some 10 minutes. When I can break, sir?
Yes, sir. Maybe 11 o'clock.
11 o'clock. Okay, sir. Okay, sir. Oh, now you understood. No, now this PowerPoint is visible or?
Yes.
No, PowerPoint, is it visible?
Visible, sir. Very fine.
Okay. Okay, now you understood about the need for energy storage. So there is now the necessity of energy storage we understood. Then I am going to come to my research topic. There are various types of energy storage. So among the various types of energy storage, I am going to focus on thermal energy storage. thermal energy storage, but you should know about these kinds of storage: chemical storage, electrical storage, mechanical storage, thermal storage, electrochemical storage. So in the thermal storage, there are various ways. That is sensible heat, like in packed bed heat storage. Some pebbles also you can store, water also you can store. That by increasing the temperature, how you are storing energy, that is called sensible heat storage. Okay. If you change the phase of a substance, and when you change the phase of the substance, to change its phase, it requires some energy, that is called latent heat. When you store energy in the form of latent heat, it is called PCM storage or latent heat storage. Then in thermal form also, there is another thermochemical reaction. By some reversible reaction, exothermic and endothermic reaction also, you can store thermal energy. So thermal energy, sensible heat storage, latent heat storage, and thermochemical storage. So there are various materials. I will come to that. And in addition, chemical form hydrogen storage. Hydrogen is the heat value is, latent heat value is very high. If you are, but still there are some problem in the storage. Hydrogen storage becomes little. So, but now it is, I think it is almost, we are going to, from the research stage to commercial stage, is hydrogen storage. So that is also a lot of research is going on. Not only hydrogen storage, in any storage technologies, now the whole world is pumping money like anything for research and development. The whole world, all the research-oriented countries are investing lot of money on storage technologies, because they all understood that the storage is going to play a major role in the energy sector. So electrochemical battery storage, supercapacitor, and hydrogen storage, thermal storage, PCM storage, all flow batteries, in all kinds of storage, the research and development investment is very, very high in the last 10 years, and it is going to happen in the next 15 years, next to 10 to 15 years. Till this energy storage become very cheap, like solar. Now the solar energy, producing solar energy either for thermal form or electrical form become very cheap, but storing energy become expensive. Am I right? So storage technology has to play a major role in the coming years. So a lot of research investment is being made by most of the developed nation. Our country, India, is also, even DST, UGC, everywhere, this lot of funded projects. If you see, out of that, in the energy sector, some 40% fund is given to storage technologies. 40% of in the energy sector, MNRE or DST, in the DST, there are several initiatives to sponsor project, material initiative, building initiative, and water initiative, and clean energy initiative. All these initiatives, if you see, energy storage initiatives also now have come. So in all these initiatives, if you see, again, the projects based on storage means it has received attention, and several projects are under this scenario. Understood? Because I have received one project under material, also received one project, material initiative under research. One building initiative also I have projected for PCM for building application, and I got a project. And water project also I have projected something in related to storage, and I got a water storage also project. Understood? So this clean energy initiative also I have received. In everywhere, the storage, even I am projecting only thermal storage, but there are many people projecting supercapacitor, this other kind of storage like hydrogen storage, biogas storage, this flow batteries. This recent type of advanced type of electrochemical batteries. All these areas are receiving lot of attention. Okay. So in the energy sector, storage is going to play a major role. That to stress that only I am repeatedly telling what are the avenues available. Okay, energy storage technologies. So these are the various technologies at a different level, based on the power requirement, which kind of storage is better, and based on the time also, whether it is for a long duration or for a short duration, the different kinds of storage is taking place, getting momentum. Pumped hydro storage is the ultimate storage for electricity storage. As of now, it is the only technology for large capacity storage for electricity, pumped hydro storage. But next, compressed air energy storage is also playing a role, but still it is not very expensive in the sense that turnaround efficiency, round trip efficiency is very, very less. That is why it is not taking momentum, but a large focus is on what storage. This electrochemical battery only people are focusing. But I am suggesting this thermal energy storage, how it will play a major role in electricity sector also, I am going to tell. So our mechanical engineers, what we can do, mostly I think most of you are mechanical engineers, maybe other discipline engineers also. So for all discipline, the storage has an opportunity. So thermal storage is going to play a major role in electricity sector also, to make the grid smart. That's what I want to stress. Why I have told about all this electricity part also, because there is a large potential using thermal storage for electricity storage application. That means finally to promote solar energy. Am I right? Finally, to promote solar energy, how this thermal storage will play a major role. That is what that is the crux of my research. Present status of various energy storage technology. Energy storage is a necessary option for future decarbonized system, complementary to other flexibility and energy security solutions. So you can see here what is the stage of every technology: research and development stage, demonstration and development stage, and commercialization stage. So now you can see this. There are many stages. This hydrogen, compressed air energy storage, supercapacitor, flow batteries, flywheels, all are in research and development only. But this ice storage, what you can see, ice storage, cold water storage, compressed air energy storage, CAS, one kind of compressed air energy storage. These are all demonstration and nearing deployment. And this pumped hydro storage is the already well commercialized, and cold water storage for air conditioning application also well commercialized. Okay, ice storage also now well commercialized, but it is a demonstration stage, but now it is well commercialized. Ice storage. Underground thermal energy storage is well commercialized in cold countries for space heating application. Cold water storage is well commercialized in hot countries for air conditioning application. And pumped hydro storage is well commercialized for direct electricity storage application. Whenever excess power is there, you can pump the water to the dam, and it is stored as potential energy. Whenever you need excess energy, then you reverse the water, then you can generate electricity. So that is well developed technology. That is the well commercialized one. Then pit storage, that is underground thermal storage and pit storage are for space heating application. It is seasonal storage. So seasonal storage means in cold countries like Scandinavian countries like Norway, Sweden, Finland, and other Canada, these countries, and North Europe countries, they store heat energy under the ground during the summer time, and they take that energy for their space heating application during the winter. That is well commercialized technology, because otherwise expense is very high to heat their room during the winter season, because even thermal energy or electrical energy, whatever they use, it is very, very expensive, because during the winter season all the 24 hours they need to heat the whole entire building where they live. So these kinds of technology has attained already well commercialized and stage. Cold water storage is for air conditioning application in hot countries. It is being used, but still it is not well commercialized. Technology is well proven, but awareness is not created to the large extent. That is why that storage is not well commercialized. Awareness, technology wise, it's a well proven and well demonstrated, but awareness is not created much. That is why it is not well commercialized. I can say this cold water storage and ice storage also, it is well proven and well high good economy is also there, but still lack of awareness, it is not well commercialized. So now you understood about the various types of, so mechanical engineers, when we are able to prove some technology very cheap compared to other type of storage like electrochemical storage or other flow batteries or hydrogen storage, then this technology will have an edge over the other technologies. But still our role is to make this material side, a lot of research is every day some improvement in research is required to make this technology cheaper and competitive with other storage technology, right? So you can say, why I'm telling this, there was a heavy competition between solar thermal and solar photovoltaic some 10 years ago for power generation, because all these years we have been generating electricity from what? Electricity from fossil fuel, coal and other fossil fuels only. But what happened, because of the international environment organization thrust, push, all the countries have changed their power generation scenario towards renewable energy. Technology means what? Lot of research development will take place immediately. But 2010, solar thermal also the prime source of energy, people thought. But what happened, this solar thermal technology, that time the investment for 1 megawatt power generation was 16 crores per megawatt investment required. But 2010, solar photovoltaic, the investment requirement was 18 crores. 18 crores. So solar thermal also, a lot of people invested money to go for power generation through solar thermal mode, heliostatic tower and Fresnel collectors, also high concentrating collector technology became that is emerging one. But suddenly what happened, this material side, people they made lot of breakthrough, and these photovoltaic materials panels cost became very low compared to now. For every year it became 16 crore, became in 2012 it became some 14 crores, 2015 it became 7 crore, 8 crores or like something, and now it is some 2.5 crores per megawatt. So obviously nobody will generate power through any other mode. Windmill, okay, windmill still has an edge over some 3.5 to 4 crore per megawatt. But the power generation is little more than solar photovoltaic. That is why the wind is still in the market. Okay, because per megawatt the duration, 1 megawatt means the total duration which generate power means it is some 1.5 to 2 times more than solar photovoltaic. Solar photovoltaic. Pardon? So solar photovoltaic is some 2.5 crore per megawatt, but every day some 8 hours or 6 hours only you can generate power. That too, that peak power you can generate for 2 to 3 hours. That means the capacity what we mentioned is peak. Some 1 megawatt peak means that 1 megawatt you can generate only for some 2 to 3 hours. Okay. So solar power we understood, and wind energy. So these two are still in the limelight. The large capacity wind turbine and photovoltaic became successful. So solar thermal power generation, now it is there is no more, nobody will go for solar thermal power for power generation. Okay, but there is an opportunity. But there solar thermal has lot of other opportunity in process industrial and commercial and residential application in various ways. But for power generation, it is now, it is nobody will go for solar thermal for power generation unless our mechanical engineering group proves that there are lot of combining with some water generation, cool generation and process heat utilization. This efficiency, solar thermal power generation is some 60%. Total power utilization is some 60% if you are able to prove. Now this solar photovoltaic, the total efficiency is only 17%. Solar thermal power generation is also maximum 20%. But if you are able to prove some polygeneration way, and if it is proved the total capacity is high, and if it is well demonstrated, then there is a chance for solar thermal for power generation also will emerge, Otherwise, solar thermal is for process industrial application and other major, there are several other applications where solar thermal energy could be utilized. But still, solar thermal for concentrating collector, particularly this now the present compound parabolic collector for solar thermal application is going to, commercial application is going to come in enormous way, because that is there is no tracking required, and that technology will attain a lot of scope in industrial application in the coming years. But for power application, the price is very high. But now the thermal side, what opportunity is there? Even electricity generation that cannot be utilized with the support of thermal energy storage. Understood? Even solar photovoltaic people can generate power. All the power, if it is generated through photovoltaic, means what? That is, energy is available only for 4 hours or 5 hours. But that has to be stored. That has to be stored for 24 hours requirement. How it is possible? Using various storage technologies. So now I am telling, wherever the application is thermal, wherever the application, whether it can be electrical energy generation through solar photovoltaic, but if the application is thermal, there are so many applications I can point out. For example, this lot of preservation, food preservation, medicine preservation, agricultural products preservation. You know, the 30% of the agricultural products produced in this country is being wasted because of lack of preservation facility. So at the source place where it is cultivated, there if you make a lot of preservation facility for the cultivated products, then this utilization or the utilization of the produced product will be more. So lots of technology growth is going to happen. All this water, it's a cool energy requirement. There are lots of drying application. Food products, whatever you generate can be dried. Solar energy only you need. That solar energy can be stored and can be utilized. Solar energy utilization, drying application, process industrial application, and for cool energy, for space cooling application, it is very enormous. Okay, so space cooling. So even for passive construction, it is with some technologies of understood. So thermal energy requirement is very high in many applications where electrical energy is used. Now I am telling, in those applications, we can think of we need not think of electricity storage using battery. Let us use electrical energy, let us generate electrical energy, and that because producing electrical energy now became cheap. Right? Whether it is a cooling energy, also now vapor absorption mode may not become economical. Storing, generating energy using electrical energy, through that is vapor compression system, which is operated through electrical energy, and that produced energy you store it and use it whenever required. That technology will become very popular. Understood? So vapor compression system technology and any drying applications and several applications where thermal energy is directly used or electrical energy is used for thermal application. In all these applications, thermal energy storage will play a major role. So this, I think you understood the crux of what I mean. So it is thermal energy storage, almost in the total energy utilized, some 30% of the energy utilized is for direct thermal applications. In all these places, you can think of thermal energy storage. Okay, there are some 10% you can think of using compressed air storage, because the cleaning and some in the where automobile industries for tire inflation and many cleaning purpose, compressed air, what is that? Pneumatic applications. In many applications, compressed air is being used. So compressed air also you can generate whenever solar or wind energy is available, then you store it at compressed air. Okay. So whatever form we are finally using, in that form we need to store. That is my stress. That should be your takeaway from at the end of this lecture. What energy you want to use, in that form we should develop technology to store energy. Then it is the cheapest form. Now, but if we don't do anything, we will be controlled by electrochemical battery. Even for our thermal requirement also, what will come, thermochemical battery will be dominating, because all mechanical type of storage we ourselves can do in our own country, and we can make systems for our requirement. But thermochemical storage means it can be produced in any country and it can be imported very easily to our country. Understood? So the people, the developed nations will never promote this thermal storage technology, because it will become indigenous. It will become indigenous, and nobody will borrow the technology from other countries. So we need to promote this technology for our country's growth. But okay, we should not, because another 60% requirement is for electrical energy requirement. So that energy can be stored only through electrical mode. But we should not think all the energy requirement storage is to be done by electrochemical battery or other hydrogen storage or whatever it be. Hydrogen storage is also one another new good technology, because whenever solar is available, we can convert into solar, we can convert into another fuel, we can generate fuel, water can be splitted through photovoltaic, and we generate hydrogen, and hydrogen can be stored, means that is also another ultimate way of storing energy. Okay, so this in the electric vehicle, okay, now electric vehicle is coming in a large way, but hydrogen operated vehicle also there is a good scope. Hydrogen operated vehicle, if our mode of storing is hydrogen storage is very popular, means that kind of storage also will become very popular. That is also sure. Okay, thermal. Now I am coming to thermal storage. Thermal storage. Now all this time I have been initially I talked about electrical energy, all this renewable energy. You may think that I may tell something different, but now you would have understood why there was a lot of stress on need for this energy storage. What is the need for renewable energy? All this I have given a introduction. You can say till now whatever I have given is an introduction, but without this large introduction, you will not appreciate this whatever I am going to tell. That is why I took a lot of time to give a very lengthy introduction. Okay, thermal storage for solar application and building application. That is my talk. How this thermal storage can be utilized for solar and building applications. So in the emergence of new architecture and solar energy utilization, this thermal storage is going to play a major role. Storage is natural. Why this natural? What I am telling, what I mean to say natural. Any technology, all these inventors, they found from nature only. Even this aircraft, the bird fly, from that only the people would have got an idea of designing the aircraft. Am I right? In the same way, any technology development, the person who invented, he would have seen that from the nature. Okay, so nature only will give an opportunity to invent something. So an innovative technologies are all coming from nature, and also when the necessity comes, that human brain will work very fast, and the nature will give a pathway to invent a lot of things, a lot of new technologies. Okay, like that human system, if you see our human system also, we need a lot of energy for our day-to-day work. Every time except when we are sleeping, all the time we do something. Even we watch movie, means our eyes are strained. So eye needs energy. When we read, our brain is working very fast, and our brain needs a lot of energy. Am I right? When we are reading or trying to learn, understand something, our brain is working fast. And otherwise, people are working physically means that requires energy. But we don't give a, we don't what? Eat food. Our only three times we take food. But that food, our system, human system knows how to utilize this energy for all the 24 hours. Am I right? Whenever energy requirement is high, this food stored is coming out. So it's a buffer storage, and a long-term storage is also there. Even a human person is not consuming food for 7 days also, he can sustain, because the stored energy will come out. The stored energy will come out, and that energy can be delivered. So how it is storing? It's storing in for long-term storage means it is storing in the form of fat. Otherwise, it is storing in different forms, and that energy is coming out. Okay, so now we understood our human system is also storing energy and releasing. So if you start seeing how this energy is stored in human system, that will be the ultimate technology that will win the game of this energy storage technologies. Okay, so uh, now we being a mechanical engineer, we have our role is to develop this thermal storage technology for the best to our best effort. We should project what extent we can project this, and sometimes our technology also may fail. Hydrogen storage becomes cheap means what? Hydrogen storage will dominate everything, right? After 10 years only we will know which storage, because now only we are talking about various types of energy storage technologies. But after 10 years, one of these technology will have an edge over all other technologies, and that technology is going to win all the other storage technologies. Yes, sometimes hydrogen storage or some kind of flow battery it may be, but for thermal storage, I feel this kind of ice storage and some materials and chemical reactor type of storage will play a major role for several applications. This have some 20 to 25% of share will be there for thermal storage in the total energy storage market. That is what I view like that. Okay, otherwise this hydrogen storage may become popular, or battery storage is some electrochemical. If they make the things very cheap, that will become popular. Okay, if electrical energy can be stored in a very cheapest form, then no other storage will win. That is sure. Understood? If electrical energy can be stored and retrieved, so charging and discharging in the electrical energy, some whatever we store out of that 80% we can retrieve means with the lowest cost, that will be the ultimate one. Then this thermal storage, all other storage will fail. But as of now, this is not cheap. Electrical energy storage is not cheap. Okay, what is thermal storage? So already I told you, so you can store energy in the form of sensible heat storage by increasing the temperature of a substance, to some higher level, whatever temperature you want. So sometimes it may be some 80 degrees centigrade application means some material which can, so water, it's a good sensible heat storage medium, because it is freely available, and it has the very good property. Among the various sensible heat storage material, water is best because the CP value among the various material available, that is the highest, 4.1968 kilojoules per kg Kelvin per degree centigrade. So per degree centigrade rise or per Kelvin rise, it can store 4.18 kilojoules of heat. That means that is the best material available. Okay, sometimes water we cannot use for some application. If the requirement is more than 100 degrees centigrade, we need to use pressurized water or some other oils or something else only we can go. Am I right? So some thermic fluids can be utilized to store energy at a higher temperature in the range of some 150 to 200 also we can go. So many of the process industrial application, we need heat in the temperature range of some 200, 150 to 160. So for those applications, this thermic fluid can be used. So something like Dow therm, And there are so many thermic fluids have come in the market. These fluids can be utilized to store energy. And for small applications like some sensible heat, some 45 degrees centigrade, you need enormous. Then even the sand, pebbles, some concrete structures can be utilized to store energy abundantly. Right? It's a very cheap form. You can pump energy to the concrete or stone or underground. So this is what these people succeeded in the north, where these Scandinavian countries, for storing energy in the temperature range of some 30 to 40 degrees centigrade, and that energy is retrieved during the winter season for space heating applications. They all use underground storage. Underground, they store it in the pebbles, and some natural rocks are there, means that rock, they heat the entire rock. Okay, some passage will be made and the air to flow through the passage of these rocks, and that cool air will be supplied through during the winter time, and that energy will be retrieved. So this is called sensible heat storage, which is being used extensively for space heating applications. Space heating in our country also, we can think of this kind of space heating in places where this some hill stations, and North India, some regions where the winter time we need that is what heating for residential or commercial applications. This kind of storage is well demonstrated and well successfully commercialized. That technology, but it is not available in India. We can bring this technology to the places where Kashmir, and there are some places where during the winter time we need space heating, right? So this technology can be well that is well economically we can utilize, because it is well commercialized in those, but it is not brought to our Indian system, that I am sure. But people are using some kind of heating with the firewood and something else only people are using, or electrical heater is being used for space heating. Electrical heater is being used for space heating. Okay, this is one of the important applications, sensible heat storage. So since this is sensible heat storage, by increasing the temperature of the material, so temperature to any level, I told you the best material is water and pebbles, sand and oils. Oils can be used, thermic fluid, because naturally the artificially produced oils are there. So that because some oils will degrade. So adding some chemicals, that property can be maintained for a long duration, because if we use this as a storage material, that in cycle it should work for some 10 to 15 years. Then only somebody will invest. In 4 months or 5 months, if it gets degraded, nobody will use. So any energy storage material, the life of this material which we project also is important. So if we use the same material for charging and discharging every day, if it has a cyclic operational, some 5,000 cycles, there is some sound. So I request all the audience to mute.
Please mute.
Yeah. So if 5,000 cycles, if it comes, means 365, 5,000 divided by 365 is nearly some 14 years it will come. Am I right? So 14 years every day one cycle, charging and discharging you can make. So when you select some sensible, it's a sensible or latent heat storage material, what is the life cycle of that material, that you should ask immediately. So if it is 5,000 cycle, means it will come for some 15 years. So if you develop some new materials, you should have that in your mind. That is in minimum of the material will work for 1 or 2 days in your lab test. But after 1 month, if you see, the quality will become totally different, and that will never work as a storage material. Okay. So this the repeatability, that means repeatability is different. It is life cycle. So it should serve for some 5,000 cycles. Then only you can call it as a sensible or latent heat storage material. So sensible heat storage, Otherwise sensible heat storage material, even the solar pond, you can consider this as a sensible heat storage material under the I think you know the principle of solar pond. So it is through mass transfer we can push the heat to the bottom of the bottom of the lakes and ponds. If you have some salinity at the bottom, due to mass transfer, that heat will be transferred to the bottom of the pond. So that is also being used as one of the best sensible heat storage system for space heating applications. In these, because for space heating application, what you need is slightly some 24 degrees centigrade only. If you are able to store energy at 40 degrees centigrade, it is enormous. But the requirement is very enormous, am I right? For which you should not use electrical energy, because very easily you can use solar energy and store it for various ways, in various ways. For any space heating application, I strongly recommend this solar energy during the summer time can be utilized and store it under the ground or in pebbles or in solar pond, and that can be utilized during the requirement. Okay, because which is successfully being used in some 4 or 5 countries in the North Polar region. Okay. So it's a very successful commercialized technology. If you go to Norway, Sweden and all, the space heating from underground storage and that heat energy retrieval during the winter time, winter time is very popular, very popular. So that technology we can promote in many of the North states.
Hello.
Yes.
Sorry, sir, in between, because this concern was being felt with me. This underground storage in pebbles.
Yes, sir.
So what are the factors which help in preserving that thermal energy? Temperature factor, or then second is the insulation.
Yeah,
how we are able?
No, earth itself is an insulation. This under the ground, there is a natural package maybe there. Otherwise, even you can make some artificial way of that is some container like structure which is very cheap, and that if it is under the ground, that is required.
Normally actually the concern was that when we go for we had fabricated one testing equipment where we are providing insulation on the walls, because it was on the ground floor. It was on the ground floor, and walls in winter they are so cool.
Okay.
So I was having a feel that whether along with the variation of temperature, do we require some insulation?
Yeah, that insulation. Okay. Now what I am telling, if it is a very small scale, if you think, then that small area is very insignificant when you compare to the total large area. Okay. But if it is done for in a large scale by a community level storage, then this leakage, that is the without insulation also it will work. Understood?
Right. That's good. That's good.
Yeah. And when you plan it for a small some one building application, then this without storage it will not work. But for the whole entire district level heating storage means, then this boundary is very negligible considered to the inner region.
Right. So that is true. Very true. And sir, then reverse cycle, how the reverse cycle takes place?
Yeah, then you can take that water is sometimes the water through supplying water it is taken back, or supplying air also it is taken back. So mostly it is sending water, because water the heat transfer coefficient is very high, no? So whenever you want that water through water supply and then taking some warm water and use it for space heating is the ideal way.
Yeah, and a little one, sir, those devices for doing all those operations, these are mechanical devices or?
Yeah, it's all mechanical devices. What I don't know what you are asking. I don't understand.
No, for transfer of water to make it contact for taking out the thermal.
No. What's till you bring that? No, in most of the cold region, this in the cold countries, this it's like a radiant heater. like our
Oh,
radiator. No,
okay.
that kind of radiant heater is only there in all the houses. Even without underground storage, they produce hot water in a boiler, and that water is only supplied to
Yeah,
the radiator. So the same
right, sir.
concept you can make use of. Yes.
Right, sir. Right. Thank you, boss. Thank you, sir. Thank you.
Yes. Yes. Yeah. Okay. Now this is a sensible heat storage. I think now the time is 11. So we will break for some 10 minutes. Then I will start the latent heat storage, which is my research area. Yeah. I think since he asked several doubts, now I think how it is being implemented also, because I didn't explain that. Hence, having he asked, it's a correct question. I think the person who asked is already involved in that kind of research. Am I right or okay?
Professor Chandra?
Yeah,
Okay,
now
sir.
he's not there, I think. Okay, so
sir, one participant, Dr. Mahesh. Dr. Mahesh wants to ask.
Because I have written one chapter on sensible heat storage in one LCV solar heating and cooling. That time only I have gone through all these kinds of storage system which is available in space, but I haven't any real research on sensible heat storage system. But when I wrote that book chapter, I understood lot of things well commercialized. That chapter is available in solar heating and cooling, one book by LCVR. My sensible heat storage for solar applications.
Right, sir. Right, sir.
Yeah,
Definitely,
that gives
sir.
Mostly that chapter is giving on seasonal storage for building applications.
Right, okay, sir. That's good.
Okay.
Thank you,
Otherwise,
sir.
my research focuses on thermal storage, which I will start after this break. After some 10 minutes. I think now it's 11:03, 11:15. We exactly at 11:15 we will start, and till 12:45 we will proceed.
Okay, sir. Okay, sir. We'll start.
Right, sir. Thank you.
Can I ask one question?
Yes, if you have any question now in thermal sensible storage part, if you have any question, you can ask. Yes.
Sir, any implemented case study of solar pond in India or in
solar pond is in Pondicherry, Aravindo Ashramam, they have made a solar pond. One professor, suddenly his name is not coming, he has made. But solar pond, they have made its experimental, it's not for solar, because in India, solar pond for space heating, nobody has taken attempt for a large type of storage for space heating application. No. There are some demonstration plants, not real-time plant also for space heating available in the other part of the world, but not in India. In India, to my knowledge, in Pondicherry, Aravind Ashramam, some 10 years back, he was maintaining very well, but I do not know whether he is maintaining still, whether he is maintaining or not, I am not sure.
Okay, but there is a huge potential in India for the battery storage, because in a lot of renewable energy.
Pardon? There is huge potential?
Okay, voice is some problem, I think so. Dr. Mahesh?
Yes, sir, I am asking.
Yes, yes. Please go a short question.
Okay. Sir, in sensible heat storage, why is in Indian or most of the power plant they are not using that sensible heat storage? Because the cost of the material is very less compared to other materials like latent heat material, PCM material. But this sensible heat storage, I think so.
No, what storage? I don't get you. What storage?
Sensible heat. Please.
Sensible heat storage. No, sensible heat storage is this water for solar water heating system in Bangalore. The solar water heating system became very popular. You know that the technology is very well commercialized in Bangalore city. It's a water storage only. It's a sensible heat storage system for our day-to-day requirement. Because why it became very popular in Bangalore city, this solar water heating system with the water storage, because in all the 12 months they need hot water for bath application. But in Chennai city or some hot places, if solar water heating system with the storage, if we install, people will use only during the winter time for some 4 months. So utilization is less. Okay, so that is why it is not becoming popular in other cities. If in hill station and most of the hill station in Himachal Pradesh area also I have seen solar water heating system very popular, and Bangalore city it is very popular.
Okay, sir. Thanks. Okay, sir. 11:15 will start.
Okay, 11:15 will start, and another 10 minutes is there, no? Okay.
Okay, sir. Sir, you may keep in online. No, are you leaving?
Okay.
Because 10 minutes gap only. You may keep in. You may
Online, let it be there as such.
Yeah, you may mute. You may mute the voice.
Yeah, I will mute. Yes, sir.
Yes. That's me. So that will continue.
Yes, sir. Yes, sir. Yes.
Okay, sir. Thank you, sir.
Thank you, sir.
Dear participants, we will meet again at 11:15 today, 11:15 a.m. Thank you. Bye.